Hi, I'm Jonathan Downey, the founder and CEO of Airware, and today I have with me another Jonathan Ballon, who is the Vice President and General Manager of the Internet of Things Group at Intel. Welcome, Jonathan.
Thank you, Jonathan.
At Airware, we often think about the Internet of Things spreading into the skies, and that's one of the things that we're really focused on here at Airware. Could you tell us a little bit more about what the Internet of Things Group at Intel does?
Sure. The Internet of Things for Intel is really just the extension of the idea that anything that can compute and connect will do so, and that creates opportunities well beyond what we've seen historically in PCs and tablets and phones, and it's actually not a new idea. We've been putting Intel technology into devices for decades, everything from retail point of sale systems to MRI machines. I mean, any device that you can imagine that thinks will usually have Intel content inside. What's interesting about IoT is now those devices that have historically been smart and intelligent have the ability to connect to the network, and when they do, they can communicate vast amounts of data about how they're performing and inform their users and their owners in a more intuitive way.
For those who may not know, Intel made an investment in Airware last fall. Why invest in a commercial drone company like Airware?
I think people have been focused on how do they get the drone itself performing at a certain level, but really the opportunity is how do you get that drone operating in an enterprise use case environment, whether it's in the industrial category or in first response. There's a number of things, and those gaps were barriers, I think, to adoption because there were no standards. And what we like about Airware is, you've built an integrated platform of hardware and software that allows it to be really easy to deploy these into a commercial or enterprise environment so that aligns to the customer's business and it starts driving real value for them a lot quicker than they would historically. It used to be it was just about how do you move a drone around in a 3D plane, and now it's about how do you have that drone have all kinds of autonomous software-defined capabilities that start first with safety and making sure that that drone is operating safely in its environment. So motion control, collision avoidance, and those types of basic flight control applications. But where it's going is the analytics that will run on the drone itself, with the sensors, the camera, and incorporating that, I think is what's going to really differentiate the ability to drive some of these enterprise and industrial use cases that we see.
What are some other technology spaces that you think will end up substantially benefiting the Internet of Things?
One thing that I think is highly analogous to what's happening in drones is what's happening in vehicles today. So we're doing a tremendous amount of work with some of the leading auto manufacturers around the world to bring intelligence into the car. And what people don't realize is that cars are really becoming almost like a mobile data center. The amount of compute and storage and comms that goes into a vehicle and the software and applications and analytics that run on that is staggering. In fact, most people don't know this, but the average car on the road today actually has more lines of code than the Hadron Collider.
That's incredible.
Or even Facebook. It's truly staggering, and there's more and more investment going into that.
And it's being connected to the cloud.
And it is being connected. And of course, that's raised some concerns for people because once you connect an asset, then you expose some potential vulnerabilities. And we've been pretty vocal that we believe our architecture is the most secure architecture in the industry. We actually embed security below the operating system at the silicon level, and then all the way through the comms layer and back into the data center. So some of the breaches that you've seen recently, those are not happening on, fortunately, on Intel architecture. So but we think that the industry is going to get past that, and the use cases may not be entirely the same, but the early applications are certainly very similar. How do we make the vehicle more secure and safe for its passengers and for the things in its environment? So collision avoidance, lane change assist, anti-lock braking, and some of the basic capabilities. Then you get into adaptive cruise control, and you start bringing in all of the autonomous driving and assist systems that will enable cars to operate autonomously in a system in their environment. And we see the same thing happening with drones? How do we bring software-defined capabilities into the drone so that you remove the burden of the operator on some of those basic features and you allow them to drive the real enterprise or industrial value that they're trying to deliver?
Which do you think we'll see first, 100,000 drones deployed with commercial businesses or 100,000 driverless cars?
Well, technically, Tesla is shipping driverless cars today. They just haven't turned on that feature unless you're on private property. But they're not shipping 100,000 cars yet. So, I'd have to say, if you read the reports, it's probably going to be a coin toss. It's probably going to be a coin toss.
What are some of the lessons from the long history of Intel that could be applied to the emerging drone landscape?
Well, I think you guys have figured a lot of it out. Part of it is tightly integrating hardware and software, which you're doing. I think also it's having an end-to-end architecture so that you're not just playing in one component part, but you have a value proposition across the whole, and truly making it easy for customers to deploy. Because if there's any barrier today to technology adoption, it's that there's a lot of choices and customers have to go through the burden of that selection and integration process themselves. So the degree to which leading companies can come together and say, here's a predefined solution that's very easy for you to deploy in your environment, where you're going to see real productivity and measurable results within a reasonable time frame, say 6 months to a year, that's going to really drive and accelerate, I think, the adoption.
Could you tell us about what's next for Intel in the world of drones?
Well, hopefully we're going to be deploying lots of Airware-enabled systems at every stage of the market, but we're seeing just a tremendous level of creativity from customers in terms of how they think they can use drone technology to better improve their business. I mean, the most publicized is probably Amazon using drones for package delivery, but there's also everything from first responders and how do you get help from point A to point B faster than you could over traditional methods so that you can begin that intervention process when there's a disaster or an accident, and bringing expertise to remote locations. I think that's one thing. Also, the ability to use the sensors on the drone to be able to do site surveys, to make environments safer, to be able to identify gaps or defects in certain deployments, like in an oil pipeline or a wind turbine. And
predictive analytics.
Absolutely.
As part of that.
So it's not just how do we observe what's happening today, but how do we use that data to predict what could happen in the future and intervene before problems occur.
Jonathan Ballon, General Manager of the Internet of Things Group at Intel, thank you so much for being with us today.
Thanks, Jonathan.